All right, hey everyone. It is day 6 now of Advent of Code 2021. I'm excited to get started today. One thing I'm going to try and start doing is making these videos a little shorter. 20 minutes is kind of a lot to ask, I think. I'm just going to jump right in here and get started on part one. I've already downloaded the input and read through the puzzles, so I'm going to start trying to figure out how fast these fish spawn, and then I'll walk you through what I've written afterward. Cool. Okay. Um, that worked. It actually didn't take very long to write either. I don't think Mateo is going to be happy about how fast it runs, but it works. So I'll walk you through what all I did. So the first thing is it's a very simple, as you can see, it's 16 lines of code. So I'm importing sys here just to make sure that we can that I can switch between the test dataset and the input dataset quickly. And then the fish array is just a numpy array of all the we get this initial state here, 34312 for the test data set, and our input data set is obviously much bigger. And then we set the day to 0, and then while the day is less than 80, so for 80 days, we subtract 1 from all the fish, and then the spawning fish are any fish with less than 0 days until they spawn. So those fish get set to 6, and then if there are more than 0 spawning fish, we create new fish that have 8 days until they spawn. And then we increment the day, and then print how many fish there are at the end of 80 days. And it works. It's slow. It's very slow, but it works. So now it's time for part 2, which seems to be just making it take longer. So I am going to do this with a very inefficient. I'm just going to do the exact same thing. We can even actually, you know what, we can. Nah, we'll do it this way. I'm just going to copy paste this. How funny. Maybe after I make this, I'll think of a more efficient way to do it. So you can see that's how long it took to just do the 80 days, so 256. I wonder if instead of you know what? Once I'm done with this and we have the right answer, since this was so quick, I might try and write up a faster version, because I think if we store the number of fish at each day rather than a day for each fish, it'll be way faster. I just realized that, because if you think about it, this is a 400,000 element array. That's just going to be slow no matter what we do. It's going to be even bigger for 256. Let's look. Yeah. Python, I'm sure, is using. Oh, it's actually not using very much memory. Huh. Well. Anyway, we can get started writing that. So. Okay. I didn't actually need to go into fast mode for that. It was a very simple bug. So basically what was happening was, I realized it as soon as I printed out the fish, is that you can see that I wasn't deleting the -1 value, so I was way high because every time new fish spawned, I would both copy them to the 6 and I would keep them at -1, so they'd keep propagating backward, and you can see things just went kind of crazy. So now this faster solution works much better, it seems. I don't need to print fish anymore. So let's actually let's make sure it works. So fast6 input. You can see how much faster that was. And here 387413. Boom. So now if we do if we just copy this whole thing, except for setting day to 0, and then say wild day, and even though it's it'd be better to try and get this all into one thing, it doesn't really matter, and we're not resetting day, so we're not wasting the first 80 days of work. So now 256, and boom. So we wrote and got the solution from that problem before this slow one was even done. So I'm going to kill it if it'll let me. You get to watch me do my really nasty business here. So great. That was day 6. Very easy. Much easier than day 5, I think. I mean, not that either of them was particularly difficult, but I think day 5 was a lot harder than day 6. But I'm excited to see what fast and clever solutions you guys all come up with. And I'll comment this up for upload to or for when I push it to GitHub, so you can see what I did a bit better. Cool. Thanks.